I guess it's probably appropriate. I'm just going to start by like drawing, recap from yesterday, an equation, okay? So if you have absolute value equals a number, right? Whatever is inside the absolute value has two identities, right? Like it could be its positive self or its negative self. Because if you think, okay, well, what number is 4 units away from 0 on the number line? Well, that's 4, and that's also negative 4, right? So, like the answer to this one is the number 4 and negative 4, right? So if I change this and I say absolute value of x is less than or equal to 4, what I'm saying is the distance a number is from 0 on a number line is 4 or less. So always remember it's a distance, right? So like this is 4, right? So if my distance could be 4 or less, could my solutions be over here? No, because those are greater. That distance is farther away. So it would be all, like if you say I live 4 miles or less from Jersey Village, you could live here or here or here or here or here, right? And then the same can be true here. If the distance here is less than or equal to 4, here it'd be equal to, but it would be here, right? So when is this distance less than or equal to 4? Well, it would be all the space in between 4. If I look at that in 2 dimensions, right? So that's 1 dimension, it's just the x, right? But if I look at my function in 2 dimensions with x and y, there's my absolute value of x, and I have 4, this is y equals 4. Here's where it equals, right? Well, if I'm saying when is it less than or equal to 4, and I have 2 dimensions now, what I'm really saying is, when is this graph below the line y equals 4? All of this, right? That's all of our graph that's below 4. And if I just shrink that down, I get rid of the y dimension. This is what we end up having. And likewise, if I wanted to ask about when is it greater than 4, like what if I wanted it greater than or equal to 4? Well, wouldn't that just be this part? The part where the graph is above the line? And if I shrink that down and I put that on a number line, wouldn't that just be right here? Right? So don't these look a lot like compound inequalities? Okay, now we're like, okay, that's why we did what we did on Monday, because now it's going to come back. So every time I have an absolute value inequality, it's going to look like a compound inequality, whether it's going to be the endpoints outward or the endpoints inward, okay? So now, like, how do we do that algebraically? Like, this was a very basic example, but how do we do it algebraically? Well, we have to know right off the bat if we're dealing with an and or an or. So like, for instance, the one that I did in blue, does the one in blue look like an and or an or to you? Look like intersection or union?
And.
Looks like an and, right? Because it's overlapped when they meet. Okay, so any kind of less than symbol, and I would put this large at the top of your notes. I mean, I was just writing stuff here. You don't have to write that. But right here, I would write this. If you have absolute value and it's a less than, or less than or equal to, but any kind of less than, that's always going to be an and compound inequality. Think less than and, or less than equal to, okay? And if you have absolute value is greater than, or greater than or equal to, what do you think that one's going to be? Or. So think more or. More than or. More or, less than and. Okay? So if we know this, then we can apply it to more like algebraic examples. Okay? But I mean, I kind of did these with, like logically, but let's do these algebraically. So using the rules that we learned yesterday. we isolate the absolute value, then we can split, right, into positive and negative paths. Positive and negative paths. So this side would be x is less than or equal to 4. Okay, oh, but this is a less than symbol, so this one is and, right? So I'm gonna write and then the negative path, negative x is less than or equal to 4. So the one on the left is already solved. And then the one on the right, well, to solve this one, I would end up dividing by -1, right? Oh, and look what happens when we divide by a negative in an inequality. This is gonna happen a lot. We're gonna have to switch the direction of that inequality symbol, right? Okay, so now I have x not less than or equal to, but greater than or equal to -4. So here's my compound inequality. X is less than or equal to 4, and x is greater than or equal to -4. That's the compound inequality. That's not the solution, right? That's the compound inequality, which helps me figure out my solution. All right? So if I were to then make a practice graph, I would say, okay, I have a closed circle at 4, and it's less than or equal to, so it'd be going left, and a closed circle at -4, and it's greater than, because we had to flip the sign, right? And that's going to the right, and since it's and, I'm looking for the overlap. So we are now proving algebraically why this is the solution. So this one we kind of logicked our way through it, but algebraically this is why that works, right? It's the intersection of those two inequalities, so that would be our solution graph. Now I have to state the solution, right? Because this is a compound inequality, but it's not the solution set. Compound inequality. Okay, my solution set, we state that either in set builder or interval notation. And I'm going to give both. Remember, I'm always going to do both, but you will, when you give it back to me, you just do one. So bracket -4 to 4, bracket, because they're two closed circles. Or in set builder, it would be the set of all x such that -4 is less than or equal to x is less than or equal to 4. Okay? Okay, and then we can also see why, I mean, we kind of talked about logically what happens if it's greater than. That's what I did in the orange. Okay, so we kind of know what's coming, but here's why, algebraically, why it is the way that that is, right? So it's a greater than, which means it's or, more or, positive and negative paths. So we have x is greater than 4, or negative that okay. So left side's already solved. On the right side, I'm going to have to divide by -1. And dividing by a negative means a sign flip is going to occur, right? So this will be x, not greater than, but less than 4 divided by -1 is -4. Okay, so my compound inequality, it's not greater than, you don't do greater than. X is greater than 4, or x is less than -4. That's not the solution, that's the compound inequality. Okay. All right. Now, x is greater than 4 or x is less than negative 4. For these, I don't really think that we necessarily need a practice graph, but you can definitely, you know, make sure that you get why it is what it is. So, okay. So, for negative 4, greater than, closed circle, or open circle going to the right, less than negative 4, going to the left. Now we can see, okay, it's or, so they don't have to overlap, it's just what we have here. So negative 4, 4. This way, and this way. So our solution, so this one, if we choose interval notation, we have to union two intervals together. So first interval begins in negative infinity, and it goes up to negative 4, but we don't include negative 4, so parentheses. Parentheses means we're not including the endpoint. And then we have to union that second interval with it. So the second interval begins at 4, but non-inclusive, going to infinity. Remember, if you're using interval notation, you don't need curly braces because the interval notation is its own solution set, okay? But if you choose set builder notation, then you would need it. So this one would be the set of all x such that x is less than negative 4 or x is greater than positive 4. Okay? So this is our solution. This is our solution graph. This was my compound inequality. That's a practice graph. But for these, can you kind of understand that it's either going to be, I call it an innie or an outie, right? You're not going to have, with absolute value inequalities, you're not going to have those really complicated absolute or compound inequalities where you had those, you know what I'm talking about, the back of the quiz A. We're not going to have that. It's either going to be an innie or an outie. Highly classified math terms, by the way. No. Okay, so we're going to do 3 and 4, and then we'll save the rest for next week. All right, so we're going to add in some algebra steps. So we have absolute value all by itself is greater than or equal to 10. So is this one going to be and or? Or, more than, or. All right, so I know this one's going to be an or, okay? Now we can work on solving it. So split into our positive and negative paths. So we have negative 4y plus 2 is greater than or equal to 10. Or negative that, negative 4y plus 2 is greater than or equal to 10. Okay, so we can solve them. Going back to the first one, minus 2. So we have negative 4y is greater than or equal to 8. Oh, and this one, we have a sign flip on the left side, right? Because we have to divide by negative 4. So that inequality symbol is going to flip around. So we have y is less than or equal to negative 2. Everyone okay with this one? Okay. All right, I'm going to hang on to him for a second. And I'm going to go over here and distribute this negative in. So we have a positive 4y minus 2 is greater than or equal to 10. Then we can add 2 and divide by 4. So y equals greater than or equal to 3. So no sign flip needed to occur on that side. But I have to make sure I write my compound inequality, so I'm going to join these with the word or, because I need this, right? Whoops. Just happened here. All right. Now, I can either go right to the solution number line and just think, all right, it's or, so it's less than or equal to 2 or greater than or equal to 3. So close circle, less than -2 is this way. 3, close circle, go in here. Don't really think I needed a practice graph for that one. Okay, solution, where am I gonna write that? I'll write underneath. So our solution set, if I choose interval notation, I'm gonna union 2 intervals together. -infinity to -2, bracket. Y'all, why did I choose a bracket instead of a parentheses?
Closer.
Close circle, okay, good, we're all on the same page. And then I'm gonna union that with the other interval, which is bracket 3 to infinity. Or if you want set builder notation, I guess I'll put that up here. But you gotta make sure you get the variable right. What is it? It's y, okay. Set of all y such that y is less than or equal to -2 or y is greater than or equal to 3. Either one of these, that or that. Okay? Any questions I can answer before we do the last one of the day? Okay. Well, I want to do one more because that one was a less than, or I'm sorry, this one was a greater than, and we're gonna end today with this one. But here's the thing. You can't decide if you have an and or an or until your absolute value is isolated. Whoops. Okay, one more time. Are you gonna cooperate? Okay, cool. All right, so you have to always still isolate the abs value, abs val, first, before you decide if it's and or, because it might impact whether it's an and or an or if you have to flip the sign for any reason. Okay, so like, I'm not gonna split, I'm not gonna decide if it's and or until I do what to both sides? Times 2, yes, very good. So I'm gonna multiply by 2 first, because I don't technically have an absolute value inequality until I do that, right? So now I have absolute value of x minus 5 is less than 8. Now I have an absolute value inequality, meaning the only thing I have on this side is an absolute value. So is it and or or? It's a less than, so less than and. More or less than and. So this one's going to be and. Okay. So when I split positive and negative path, we get x minus 5 is less than 8, and negative that negative x minus 5 is less than 8. Okay, when we solve, this one's pretty straightforward. X is less than 8 plus 5 is 13. And in this one, negative x plus 5 is less than 8. So I subtract 5 on this side. So negative x is less than 3. Divide by negative 1. Oh, there's the sign flip. So we realize in one of these, on one of the sides, we're always going to have a sign flip, right? So this will be x is not less than anymore, but greater than negative 3. All right, so let me make sure I have my compound inequality very clear, this is the compound inequality. X is less than 13 and x is greater than -3. So we've got less than 13, greater than -3. So that's the ini, right, in between those two. So y'all don't have a number line printed for this one, do you? Right? Okay. That's fine. We'll just make one. -3, 13, open circles, in between. So that's our solution graph. And then as far as our solution in interval notation, it'd be parentheses because it's open circles, right? -3, and then that interval ends at 13, but we don't include 13. So it's a parentheses. Or our set builder notation, what are we, back to x? Okay. The set of all x such that -3 is less than x is less than 13. Okay. Now, we can have like special cases, special circumstances, that's the rest of them. But we'll do those next week. We have another entire day devoted to this.